Now, but sometimes, okay, emphasis, guys, I said sometimes, because we know the definition of titration is when you use a known concentration to find the unknown concentration, right? It's the link. But sometimes you're actually not even given the concentration, you're given the mass. So now that's where it gets, I wouldn't say tricky per se, but it's the same situation. So if you're given the mass, for example, here, they say a student dissolves 8 grams of sodium hydroxide in water. This sodium hydroxide solution is completely neutralized. Emphasis on the word neutralized, guys. Remember, we just learned that neutralization, it means a base, an acid, forms salt and water. Right, that's what we're seeing. And they say by a 50 cubic centimeter of hydrochloric acid solution. So there's a lot of information they're actually giving us here. They're telling us the mass, 8 grams, and then they're telling us the volume here is 50 cubic centimeters. But before you guys even continue any further, I said, please, please, please make sure convert your volume to cubic decimeters. So our volume will be 50 times 10 to the power of negative 3 cubic decimeters. So now the tricky thing is, we look at this, we say, we're not used to this. We were told titration, we need to know the concentration. Here, there's no concentration. But don't worry, you're not lost. What you do know is the mass. That's why I call it the 2 formulas, 1 connection. Okay, because you're either given the mass or you're given the concentration. In this case, we know the mass of sodium hydroxide. And guys, remember, what's the other formula we use here? N is equal to M over M. Okay, that's the mole formula. And here, we can use that mass, this specific mass. We can use the mass of our sodium hydroxide for us to be able to find the number of moles. Remember, it all goes back to the moles. We need to know how many moles of sodium hydroxide we have. So here, we can basically calculate how much. Okay, so we can say that we've got 23 plus 16 plus 1, because sodium hydroxide is made up of our sodium, which is 23, that, which will give us 16, and that, which gives us 1 as the atomic mass. Okay, and now if you calculate further, you're then going to find how many moles, which is going to be 0.2 moles. This tells us a story. Once again, what do we do next? This is step number 1. Look at the information that you have. Okay, you have the mass here. Next step is now we form the connection. The connection is our recipe. Our connection is our mole ratio, where we say, cool. We know that we've got 0.2 moles of sodium hydroxide. But sodium hydroxide is reacting with hydrochloric acid. So how much of it is going to react with hydrochloric acid? And that is where you do mole ratio. You say ratio of sodium hydroxide to the ratio of hydrochloric acid, and you have to look at the reaction for you to know the balanced reaction. Here, 1:1. What this tells us is that for every 1 mole of sodium hydroxide, we would have 1 mole of hydrochloric acid, ideally. But we've got 0.2 moles of sodium hydroxide. How many moles of hydrochloric acid will react with it? We're about to find out. And that is when you cross multiply. Okay, so guys, that is the purpose of mole ratio. And we end up finding that the number of moles of hydrochloric acid is equal to 0.2 moles. So essentially, you have 0.2 moles of sodium hydroxide, and it will react with 0.2 moles of hydrochloric acid. But you're not done yet. Then we go into the final step. Remember, what did they want? They want the concentration of your hydrochloric acid. Remember, titration, you use a known concentration or mass to find an unknown concentration or even mass sometimes. Here, they want the concentration. So we know the concentration formula is written like this. And we're saying we've got 0.2 moles of hydrochloric acid over the volume, and they told us it's 50 cubic centimeters, but we want it in cubic decimeters. Okay, so that is the clue, guys. Every time Do not let it confuse you. I know you're taught that the definition of titration is you have to know the concentration. But what about a situation where you actually don't even know the concentration, but you know the mass? And that is what you do here, okay? And then you find the concentration of your hydrochloric acid.